In this tutorial, we'll learn about Pandas data visualization techniques and how to create charts and graphs directly from data frames using built-in plotting features in popular libraries like Matplotlib. The first step in this tutorial is to import all the required libraries that will be used throughout the data visualization process. We begin by importing the Pandas library, which is widely used for data manipulation, analysis, and working with data frames. Next, we import Matplotlib, one of the most popular Python libraries for creating charts, graphs, and other visual representations of data. We also import the Lumpy library, which helps visualize Python objects and data structures, making it easier to understand how data is organized in memory. After importing the libraries, we configure the display settings for our plots to improve their appearance and readability. A plotting style is selected using Matplotlib's style feature, which applies a predefined visual theme to all graphs. We then set the figure size to control the width and height of the plots, ensuring that the visualizations are large enough to clearly display the data. Finally, we adjust the font size so that titles, labels, and other text elements are easy to read when presenting or analyzing the charts. These settings create a consistent and professional look for all visualizations used in the tutorial. The next step is to create a sample dataset that we can use to practice data visualization techniques in Pandas. In this example, the dataset contains information about monthly business performance, including the month name, total sales, total expenses, and the number of customers for each month. Creating sample data is important because it allows us to experiment with different types of charts and understand how visualizations help reveal patterns, trends, and comparisons within the data. The month column represents the time period for the data, while the sales column shows the total revenue generated during each month. The expenses column records the operational costs or spending for that month, and the customers column indicates how many customers interacted with the business. By organizing this information into a Pandas data frame, we can easily analyze and visualize the data using different plotting methods such as line charts, bar charts, and scatter plots. This data set will help us compare sales and expenses over time, identify growth trends, and observe how customer numbers relate to revenue. Once the dataset is created, we can display it to verify that the data has been correctly structured before moving on to visualization. Displaying the dataset is also useful because it gives a clear overview of the information we will be working with throughout the tutorial. The line graph is one of the most commonly used visualization techniques in data analysis because it clearly shows trends and changes over time. In this tutorial, the line graph is used to display the monthly sales data from January to June. The horizontal axis, also called the x-axis, represents the months, while the vertical axis, or y-axis, represents the sales values. Each month is connected by a line, allowing us to easily observe how sales change throughout the different time periods. When analyzing the graph, we can see that the sales generally increase as the months progress. Starting from January, the sales value is lower compared to the following months. As we move from January to February and then to March, the line rises upward, indicating a steady increase in sales. Although there may be a small decrease or fluctuation in certain months, the overall direction of the graph continues upward. This upward movement suggests that the business performance is improving over time. From January to June, the graph clearly demonstrates growth in revenue. By the time we reach June, the sales values are at their highest point compared to the earlier months. This indicates that the company gained more income and likely attracted more customers during this period. The gradual increase in the line helps viewers quickly identify the positive sales trend without needing to examine each individual value in the dataset. Line graphs are especially useful for identifying patterns, trends, and business growth over time. They allow analysts and decision makers to understand whether performance is improving, declining, or remaining stable. In this example, the line graph makes it easy to conclude that sales increased from January to June, showing positive business growth throughout the first half of the year. A multiple line chart is a useful visualization technique that allows us to compare two or more sets of related data on the same graph. In this tutorial, the multiple line chart is used to display both sales and expenses over several months. The x-axis represents the months from January to June, while the y-axis represents the numerical values for sales and expenses. Separate lines are used for each dataset, and labels are added to clearly identify which line represents sales and which line represents expenses. Different colors and markers make the chart easier to read and help viewers quickly distinguish between the two trends. By looking at the chart, we can observe that both sales and expenses gradually increase over time. The sales line rises steadily from January to June, showing that the business is generating more revenue each month. At the same time, the expenses line also moves upward, indicating that the company is spending more money on operations, resources, or business activities as time progresses. This relationship is common in growing businesses because higher sales often require increased investment in production, marketing, staffing, or customer support. The chart also helps us compare the gap between sales and expenses during each month. Since the sales line remains above the expenses line, it suggests that the business is earning more revenue than it is spending, which is generally a positive sign of profitability. As both lines continue to rise together, the graph visually demonstrates business growth and expansion over the observed period. Another advantage of a multiple line chart is that it makes trend analysis much easier. Instead of analyzing separate graphs for sales and expenses, viewers can compare both datasets in one visualization. This allows decision makers to identify patterns, relationships, and possible connections between increasing revenue and operational costs. For example, when sales increase sharply, expenses may also rise because the business is investing more to support higher demand. Overall, the multiple line chart provides a clear and organized way to analyze multiple variables at the same time. It helps users understand how sales and expenses change throughout the months and highlights the overall upward trend in both categories. By using labels, colors, and properly formatted axes, the chart becomes more informative, visually appealing, and easier to interpret for business analysis and reporting purposes. A bar chart is a simple and effective way to visualize and compare data across different categories. In this tutorial, the bar chart is used to display the sales values for each month from January to June. The months are shown on the x-axis, while the sales values are represented on the y-axis. Each bar corresponds to a specific month, and the height of the bar indicates the amount of sales recorded during that period. By examining the chart, we can quickly compare sales performance between the months. Shorter bars represent lower sales values, while taller bars indicate higher sales. Starting from January, the bars gradually become taller as we move toward June, showing that sales increased over time. This visual representation makes it easier to identify growth trends compared to reading numbers directly from a table. The bar chart clearly highlights which months performed better in terms of sales. For example, June has the tallest bar, meaning it achieved the highest sales value, while January has the shortest bar, indicating the lowest sales among the months shown. This allows viewers to instantly recognize patterns and differences in business performance. Bar charts are widely used in data analysis because they are easy to read and understand. They are especially useful when comparing values between categories, such as months, products, or regions. In this example, the chart provides a clear overview of monthly sales performance and demonstrates how the company's revenue improved over the 6-month period. The use of colors, labels, and properly scaled axes also improves the readability and presentation of the visualization. A scatter plot is a type of data visualization used to display the relationship between two numerical variables. In Pandas, scatter plots are commonly created to analyze patterns, trends, and correlations within a dataset. Each point on the graph represents a single observation or data record, where one variable is plotted on the x-axis and the other variable is plotted on the y-axis. This makes it easier to see how changes in one variable may affect or relate to another variable. In this tutorial, a scatter plot can be used to compare variables such as sales and customers. For example, the x-axis may represent the number of customers, while the y-axis represents sales values. Each point on the graph would then show the sales generated for a particular number of customers during a specific month. By observing the distribution of points, we can identify whether there is a positive, negative, or no relationship between the variables. If the points generally move upward from left to right, it indicates a positive relationship, meaning that as the number of customers increases, sales also increase. If the points move downward, it suggests a negative relationship, where one variable decreases as the other increases. When the points appear randomly scattered without a clear pattern, it may indicate little or no correlation between the variables. Scatter plots are very useful in data analysis because they help identify trends, clusters, and unusual data points known as outliers. Analysts often use scatter plots to study business performance, customer behavior, scientific measurements, and financial data. In Pandas, scatter plots can be easily created using the plot scatter method together with Matplotlib for customization and styling. A histogram is a type of data visualization used to show the distribution of the numerical data set. In Pandas, histograms are commonly used to understand how values are spread across different ranges, also called bins. Unlike a bar chart, which compares categories, a histogram focuses on continuous data and helps us see patterns such as frequency, concentration, and variation within the data. In a histogram, the x-axis represents the range of values divided into intervals, while the y-axis represents the frequency or number of occurrences within each interval. Each bar shows how many data points fall into a specific range. For example, if we create a histogram for sales data, the chart will group sales values into ranges such as low sales, medium sales, and high sales, and then show how often each range occurs in the data set. By analyzing a histogram, we can quickly understand the shape of the data distribution. If the bars are mostly concentrated on one side, it may indicate that most values are either low or high. If the bars form a balanced shape around the center, the data may be normally distributed. A histogram can also help identify skewness, where data is unevenly distributed to the left or right, and it can highlight outliers that fall far outside the normal range. Histograms are very useful in data analysis because they provide a clear summary of large datasets in a simple visual format. Instead of looking at raw numbers, we can easily understand the overall pattern of the data. In Pandas, histograms can be created using the plothist function, which automatically divides the data into bins and generates the frequency distribution. You have successfully completed the Pandas data visualization tutorial, where you learned how to import essential libraries, create and explore datasets, and use different types of plots such as line charts, bar charts, scatter plots, and histograms to analyze and visualize data effectively.